Satellite communications architecture refers to the system and structure that enables communication via satellites. This architecture typically includes several key components and subsystems that work together to facilitate the transmission and reception of data over long distances. Here's an overview of the main elements. 1. Space segment satellites. The primary components in the space segment, they can be classified into different types based on their orbits. Geostationary Earth Orbit (GEO) satellites, positioned around 35,786 kilometers above the equator. These satellites have a fixed position relative to the Earth. They provide consistent coverage over large areas. Medium Earth Orbit (MEO) satellites, orbit at altitudes between 2,000 and 35,786 kilometers. They are used for navigation systems like GPS. Low Earth Orbit (LEO) satellites, orbit at altitudes between 160 and 2,000 kilometers. They provide low-latency communications and are used in constellations for global coverage. Transponders, devices on the satellite that receive, amplify, and retransmit signals back to Earth. 2. Ground segment earth stations, ground-based facilities equipped with large antennas to send and receive signals from satellites. These stations manage uplink, sending data to the satellite, and downlink, receiving data from the satellite, communications. Control centers, facilities responsible for monitoring and controlling satellite operations, including tracking, telemetry, and command functions. 3. User segment user terminals, devices used by end users to communicate with satellites. These can include DSAT, very small aperture terminal, small satellite dishes used for data transmission. Mobile satellite phones, handheld devices for voice and data communication. IoT devices, Internet of Things devices that communicate data via satellite. 4. Communication links uplink, the transmission of signals from an Earth station to a satellite. Downlink, the transmission of signals from a